discussing confidence intervals. We've discussed them where we knew the population standard deviation, and we've discussed them when we knew the sample standard deviation. Well, now let's look at when we have the population proportion. Recall that for proportions, P is the population proportion of individuals who are in a specified category. So this is the population proportion. X is the number of individuals in a sample who are in a specific category. This is like our frequency, our F, and everything. N is our sample size, and P hat is the sample proportion for individuals. Recall that P hat is X divided by N. When we look at the standard error for population proportions, our standard error, sigma sub P hat, is going to be P times 1 minus P divided by N, and we take the square root of that. For the margin of error, M, we're going to use Z, alpha divided by 2, times that standard error, P times 1 minus P divided by N. And sometimes different places use P hat because P hat is what we've actually calculated. We don't actually know P. Now notice we went back to using our Z instead of our T. We're using that cumulative normal distribution. And it's because whenever we look at it, recall that we had to have a large enough sample to use population proportions. Same thing here. We have to look and make sure that we have a simple random sample, that our population is at least 20 times as large as our sample. Items in population are divided into two categories, and the sample must contain at least 10 individuals in each category. So recall wherever we did the N times P had to be greater than or equal to 10, and the N times 1 minus P had to be greater than or equal to 10. Same situation here. So when we're creating a confidence interval, we start out by finding that point estimate, our P hat. If it's given to us in percentages, please remember to change that into a decimal place. If it's given to us in frequency, remember that you need to calculate P hat and get a decimal place for it. We find the critical value, Z, and again, if we go back to the T-chart, remember at the bottom, it has our Z critical values. Let me erase these lines before they confuse us in a little bit. And so down here is where we're going to be looking at for the population proportion confidence intervals. We calculate the standard error, which is P hat times 1 minus P hat, divided by N, and take the square root of that. Then multiply it by our Z-score to find that margin of error. Always add and subtract the margin of error from our point estimate. Now I know that sounds like, oh, what do we do? What do we do? I don't know. So let's go into an example. Another thing to remember is when we're talking about population proportions, we want to round to 3 decimal places. This is a little bit arbitrary, but it gives us that percentage plus a little bit more, okay? So a survey of 145 randomly selected students at one college, so a survey of 145, that's our sample size, showed that only 87 check their campus email account on a regular basis. So our X is 87. That's the number in that specific group. Construct and interpret a confidence interval of 90%, so our confidence level is 90%, for the percentage of students at the college who do not check their email on a regular basis. So when we're looking at this, notice it says that we do not want to check it. So 87 check their email on a regular basis. We want do not check. So we're going to take 145 minus 87, which is going to give us 58 that do not check it on a regular basis. What this allows us to do is this is actually the value for our population proportion. So our p hat is actually going to be 58 divided by 145, not the 87. 87 do check their email, 58 do not check their email. So where we divide this out, we get that p hat is 0.40, about 40% do not check their email. We need to find our z-score, our critical value, alpha divided by 2. We want a confidence interval of 90%. So I come back over to the t-chart. Here's my z's, and I want a 90% confidence interval. So my z is 1.645. So z is 1.645. So we're going to take p hat minus our z, alpha divided by 2, times p hat times 1 minus p hat divided by n, square root. And our true population proportion, our true p, is going to be between that value and p hat plus our critical value times p hat 1 minus p hat divided by n, and we take the square root. So our p hat was 0.4, so we're going to do 0.40 minus our z was 1.645 times p hat again was 0.40, 1 minus p hat, 1 minus 0.40 is going to be 0.60, divided by our n, our sample size of 145, and don't forget to take the square root of that value. So our population proportion is between that and 0.40 plus 1.645 times a 0.40, 0.60 divided by 145, take the square root of that. So hopefully by this point we can put all of these into our calculator. We're going to round to 3 decimal places. I would calculate underneath here first, take its square root, multiply, round to 3 decimal places, and then take 0.40 minus that value. When we do, we should get 0.333 and 0.467. So our population proportion should be between 33.3% and 46.7%. I changed those probabilities, population proportions into percentages. So with 90% confidence, the percentage of students that do not check their campus email on a regular basis is between 33.3% and 46.7%. Now, just like with where we were talking about the z-scores, we could find the sample size that we need. We can do the same thing here to get a specific margin of error. So when we're needing to find the sample size, we take n is equal to p hat times 1 minus p hat times our z, our critical value, divided by the margin of error squared. You'll notice that only the z-score divided by the margin of error is the amount that is squared. It's just the way that the formula actually works out, if I try to do all the algebra to it and everything. Now, if you do not know p hat, if you're unsure what p hat is, if they have not given it to you, and you want to find the sample size, we're going to assume that p hat is equal to 0.5 if we do not know it. If we know it, if we know our sample size, we know how many are in that category, we can find p hat. But if we cannot find p hat, we're looking at half on one side, half on the other. So let's look at example 2. A market researcher wants to determine the population the proportion of American women who shop online. The results must be accurate at the 90% confidence level. So our confidence level is 90%. And we want an accurate error of 2%. So our margin of error is 2%. Notice it's the percentage, so change that into 0.02. Don't use a 2 in your formulas because that's 2%. We can't use percentages in our actual formulas. Calculate the minimum sample size needed to meet those requirements. Given that a previous study estimated that 59% of American women shop online, this is my p-hat. P-hat is 59%, which changes into 0.59. 0.5. So as we do this, again, I'm looking for that sample size. So I'm going to take n is equal to p-hat times a 1 minus p-hat. So this is the probability that they do shop online times the proportion that do not shop online, times that critical value, z alpha divided by 2, divided by the margin of error, squared. So p-hat is 0.59. 59% shop online. So if 59% shop online, that leaves us with 41% that do not shop online. Z alpha divided by 2, we're looking for a 90% confidence. So I'm going to come over here, and we're looking at 90%. It's still that 1.645 that we used earlier. 1.645. I want to be accurate within 2%, 0.02, and I'm going to square this. When I divide this and square it, and then multiply it by these values, I get 1,636.46. This is the minimum amount. This is my minimum sample size. Again, we're looking at sample size. I can't go down to 1,636 because I need that extra part of it. So in order to get my margin of error within that 2%, I'm going to have to use a sample size of 1,637 American women to sample. So 1,637 American women need to be sampled. I want you to try some of these population proportions with the confidence intervals. Get that formula down. Make sure that you're looking at the standard error correctly, the margin of error correctly. Practice, and then if you have any questions, let me know.